Thank you for our speakers. We heard from Shriram on audio, in Meta, and Niklas on AV1, and thank you, Jonathan, for sharing with us all your insights. We will start with a few questions. I will start with you, Shriram. So with your experience with all the scale, dealing with low-end devices, high-end devices, what is your view on server processing versus processing on the edge?
That's a great question. So at a scale, we do see a large diversity in device capabilities. And so, on low-end devices, processing on the server becomes an appealing concept. At the same time, we have a commitment towards end-to-end encryption. And so we don't decode data on meta servers. So we've invested heavily in lightweight processing on the edge, on the device. This, apart from our regular use cases, it also becomes critical for other form factors like wearables, which are pretty light anyway. With edge computing, it also comes with the benefit of lower latency. So basically, we design our algorithms so they can handle this variety in compute capabilities. Typically, you would see a low compute baseline version that's based on classical signal processing that's always available, runs on all devices. And then you have ML models or more complex algorithms that can scale depending on the available compute. So it's definitely more challenging to do everything on the edge, but makes it more interesting as well.
Another question for you. So you talked a lot about reliability problems, mainly for two-people calls. What are those reliability problems that you see more and more when the call is scaling to more participants?
This is an interesting one. There's obviously new challenges when you go to large group calls. For the part that we had a deep dive in the talk, which is on device reliability, for instance, right? You would think that those problems at the device level are common, whether it's a two-person call or a group call. To a large extent, it is. So they don't necessarily start showing up when you scale the call to many participants, but there are other cases which become very, very obvious. For instance, if you have a large call, you have a heavier compute load because you're decoding more video, rendering more video, lots of more network traffic. And we've seen that manifest, for instance, in terms of audio glitches or even echo leaks sometimes because of a high CPU load. And we need to make sure that our algorithms are scaling to that. And the obvious thing is, for instance, noise and echo become a bigger problem. The more people you have in a large call, the chances are higher that someone's going to leak echo unmuted and someone's going to leak noise. So those are things that are very, very important in that setting as well. The more obvious ones, though, like you would expect, come from the network side. Large participants mean much more network bandwidth. So you need to make sure that you have some form of audio capping on the server. But a more interesting one there becomes, you don't want the lowest common denominator in a large call to define the experience for everybody. So imagine you're all on gigabit networks. And there's one person who's on a 2G network, and you don't want everyone to send low bandwidth content for that person. You need to be able to scale such that the people on good networks, good quality. So lots of interesting challenges that come with this as well, that an RTC system needs to take care of.
Another question to you from the audience, Shriram. There is an ask to share a bit more on mixing on the server side.
Right. So like I said, because of our architecture, we typically rely on selective forwarding unit, which means we typically don't decode audio on the server. We just forward packets. Mixing is then happening on the client. When mixing happens on the client, you need to be careful about managing the network load on the client side, because if there's a 100-person call, you don't want to send data from all the 100 people down to the client. So you can have some form of intelligent audio capping on the server based on activity. I think Ben is going to talk a lot more about this in his talk that's coming later in the days. Stay tuned for that. But overall, I think we rely on selective forwarding unit, and there are other implementations that rely on mixing. These typically decode on the server and then pick the top 4 active speakers and then include them in the mix and then re-encode them. So the benefit that comes with mixing, however, is you have per hop loss prevention, recovery, packet loss, jitter compensation, and then you can also re-encode the stream based on the downlink bandwidth. So there are some benefits that come with that, but then your server compute is also going to go up.
Shiram, another question from the audience is about your opinion on those nice features such as stereo audio and spatial audio that still didn't gain deserved large popularity in the RTC industry. What are your thoughts on that?
That's an interesting one. I think now is kind of the time when we are starting to see this gain traction. The metaverse, for instance, is obviously one area where spatial audio is so key to the experience. I mean, if you're all in a virtual space, if we were having this Q&A in the metaverse, and I would turn left and I would see you, Li-Tal, and I would turn right and probably see Jonathan, and I would like you to come, your voice to come as if you were to my left. So that becomes almost a necessity. So I think the metaverse applications is going to force us to innovate and deliver spatial audio. And as a natural consequence, we'll see that coming into these regular calls as well. For instance, this experience that we're having, we're already seeing some apps come up with this experience where you have the grid view and your audio is spatialized based on where your video tile is located. So those are the first applications that we're already seeing. I think it's the right time for this to go up in adoption.
Thank you so much. By the way, our speakers are all across the world right now. Shiram is in Bellevue, Washington, Jonathan in Hawaii, and Nicholas, we caught him a few hours before the flight back from Tel Aviv. Nicholas, I will move to a question to you on your AV1 talk. So you talked about all the advantages of AV1, but what are the calling scenarios that we should still prefer to use and stay H.264?
Yeah, there's a couple of cases. I think like the naive answer is that you have a software implementation and you care more about the complexity than bitrate. But it's not always that simple. We have cases, for example, where we actually care about encode time. We encode high resolutions, send it over Wi-Fi, and we want to have super low latency. In this case, for example, there is a difference if encoding takes 2 milliseconds or 10 milliseconds, which it could do it for AV1. So cases like that, we have to wait until like either implementations are more optimized or we have hardware offload. Secondly, if you have a system where you are relying on hardware offload, probably both for encoding and decoding, I think you probably don't want to shift to a software solution. So at least on the mobile side, you're probably likely to wait until you have full hardware implementations. And then the last case I see is really like interop. H.264 will become the G711 for video compressing, if you're familiar with that in the audio space. Many companies have invested in VC equipment that they plan to keep and use for 10 more years. And they are most likely not getting upgraded with new codecs. So you need to keep it for interop.
Okay, thanks. Another question from the audience is whether you can share a bit more about the metrics for codecs that you refer to.
Yeah, I'm not 100% sure what this question referred to, but I think it was what I mentioned towards the end of the talk about we needed to develop new metrics to measure quality. Tools like VMAF are great when you are doing simulation on your computer or you're doing testing in a lab. But we at Meta, we also want to measure the quality for every single call our billions of users do, right? How do we perform actually in the field and what experience are we delivering? In those cases, we need, of course, a much more simple solution, and also that doesn't have any sort of privacy implications. And we have developed that for H.264. Of course, we track video freezes, we track resolutions, frame rate, but also encoding quality. And that's something that won't carry over automatically to a different codec. We essentially need to invest a bit more to make sure that we can have a true apple-to-apple comparison between different codecs.
Nicholas, beside codecs, what are other recent trends you see for quality improvements on real-time video?
Yeah, an area that I personally think we haven't invested enough in at Meta is video pre-processing. I think everybody has used basic background blur. We have used simple beautify filters, but there are much more advanced techniques available. We can do gaze correction, we can do relighting, you can do angle adjustment if you have the camera up here like I have. All of this is sort of this exists today. It's coming out of research. But we just need to get the sort of the quality and the performance where it is for everyday usage. After that, right, we have the going beyond 2D video into the 3D world. If you follow Meta, you are aware of our work with photorealistic avatars. That will be a super low bitrate solution that also has some quite interesting privacy advantages since you send over a very limited amount of information. And then lastly, we have the full 3D mapping and reconstructions. That's an area that I'm not an expert in really, and that's probably a topic for a whole dedicated talk.
Niklas, another question from the audience about the benefits that will come with AV2 on top of AV1. And what is the status of AV1 in the web browser?
Okay, AV2, I am not so much into that yet because, like as I said in the talk, normally for real time, we are lagging the streaming world with a couple of years. And AV2 has not really come out into that state yet. And then what was the second part of the question?
AV1 in the browsers.
Oh, AV1. At least, like it or not, I think the world is getting dominated by Chromium-based browsers. Chromium have had AV1 support both for streaming, but also for real time for a long time. So it's there and it's perfectly usable.
Another follow-up question for you, Niklas, is do you use simulcast with H.264 and AV1 in group calls, or do you change codecs on the fly based on the set of users in the call?
Yes, we are not doing simulcast with multiple different codecs currently. We are doing simulcast just for group calls, and we are doing switching of codecs depending on the capabilities of our users. I think it's a super interesting idea to do a simulcast with different codecs as well. And maybe you want to use AV1 for the lowest resolution scenario to where you can afford it, but we have not started working on that yet.
Okay, thanks. So I will move to some questions to Jonathan, and this is also a reminder for everyone. Please share your questions. As you see, we are really passing them to our speakers. So this is a great opportunity to engage with them. So Jonathan, to start with, what do you see as the biggest obstacles to innovation?
Yeah, so first of all, I think there's so much going on, and this crowd is obviously super motivated. This crowd would say all they do every day is innovate, and I'd agree with that. And you see things in room systems, for example, and high-end hardware that are just spectacular all the time. This experience is a new experience, largely coming out of COVID. The innovation in events is really amazing. But for the general consumer scenarios, it's maybe slower. And I think part of that is just I think there are two big factors, and I saw another question come in, then I'll try to address that at the same time. And that is, one is that RTC may be viewed as just good enough. When I did my first startup, Camino, my wife asked me what we were going to do, and I said, we're going to make audio quality better for calling. And she was like, how? Who cares? Really, don't waste your time. I played her some files and still totally unimpressed. So it's just the good enough thing, I think, is a big problem. And then the other thing is that, two other things. One is that large companies are gold quarterly, and these projects take a long time. We were able to write 2 audio codecs from scratch at Skype, and our own H.264 implementation from scratch, and do a really nice job, I think, with those projects, but they took years. And we had to let those developers work on those projects, at first as research, and then into the deployment phases over much longer period than a quarter. And often large organizations just don't get the luxury to do that kind of investment. And I guess the final thing I'd say is that use case scenarios like the metaverse don't come along every day, and they take a while to mature. The things that are going to stick with consumers really require some vetting in the real human environment, and that just takes a lot of time.
Jonathan, another question to you from the audience. So you mentioned in your talk the frictionless of Zoom, which led to a large adoption. What are your thoughts on the balance between that and security? Yeah,
I was really living that live. That's a great question. I was working in the finance sector at the time, and when the pandemic happened, everybody in the finance sector is on a virtual desktop and really doesn't have good support for remote and real-time media in general. Those companies, huge banks across the globe, were encouraging their employees to go out and get iPads and Zoom accounts. And all of their precautions previous, their rigid IT vetting of solutions went out the window, and suddenly everybody was on Zoom. And it came back and it hurt them. And I think almost sort of killed it at a moment. There was this big realization that bad things were happening. But the solutions to that were just password protection, a few simple rules. So the pendulum swung back into place, and I think they made the right decision to sort of err on the frictionless approach very, very aggressively, because it really drove adoption, and it made a solution that could be adopted in that moment universal. So I think that they got it right, but they had to make adjustments.
There is a very interesting question here from the audience I would like to share with you. So the question is, you shared your thoughts about the need for spatial audio. I've encountered more than one user complaining this feature is distracting for them. How to assess its usability and utility?
Yeah, that's a great one. So we implemented spatial audio, stereo audio, as an experiment, like in 2006, like the day after we got to Skype. And we demoed it to the executives at eBay, and they were super impressed. We put it into our internal builds, we used it, and some people were even sort of complaining of nausea. They were disoriented by it. And it took us a while to tune it and to get the aggressiveness into a place where it felt natural for people. And I feel like that took some time. And I feel like we got to a place where overall people were very satisfied with it. That being said, I think there needs to almost be a knob, so people can turn it all the way off or turn it up based on their own preferences. But it is also about a lot of subtle listening, about people with good ears and experience, building the solution and building it so that it's adding value rather than subtracting. I mean, I'm a huge believer in it, having used it for years in our private builds and other companies that I've been in, and really seeing the benefit of it. When you hear a dog bark, you know whose dog it is. When you hear the door close, when you hear people in the background, you know exactly where that's coming from if you have spatial audio. Whereas otherwise, it's just generalized noise. So I'm looking forward. Shriram promised, and I'm looking forward to them rolling this out to the public.
Thank you. I see more questions are coming. Maybe the next question for you, Shriram. What are your thoughts on audio video chat for games where millions of users are streaming their voice in? What will you... Oh, sorry. New questions keep coming. So what is your thoughts on the audio and voice chat for games where millions of users are streaming their voice in?
Yeah. No, it's a good one. I'm assuming that this is interactive voice chat and games, large scale. So for these kind of applications, it's typically best to just to be as natural as possible in what we convey to the users and let the brain do the work, like the cocktail party effect. So I think spatial is going to be a big part of this. There are a few things here that I would think we need to change in. One is just try to recreate that spatial separation so the brain can process multiple streams happening at the same time. And I agree with the other earlier question that we really need to get spatial right if you want it to fly. You need to have the right devices. It needs to be gentle, not too aggressive, have an option to turn it off for people for whom it may not be the right fit. But that is the way to go in future, because when you have lots of people talking at the same time, our brain is remarkably efficient at separating them if the sources are spatially separated. And as long as we provide that experience, that's going to be key in this large use case interactive chat. I think some other features that we'll need to implement for that to get it right, some of the products already have it, is have volume control on the receiver per participant or per groups of participants. So you can choose who to listen to and who to tune out. Spatial is also going to be doing that in part, right? So imagine you're in a large virtual scene where there's some people close to you, you really want to hear them clearly, but you also want to walk away and listen to what's happening on the other far end, maybe whispers happening there, like you would in real life. So these are some of architectural changes that need to happen, where you don't have audio capping to just 4 people. You're able to control volume on the receive side and so on.
I think maybe last question. It can go for both of you, Shriram and Jonathan. So is there a benchmarking or a way to measure that we are close enough with our audio to realistic and real life audio? So how can we know that it is enough? This is like real quality.
I can take a stab first, and maybe Jonathan, you could add on. It's I think there's 2 parts to it. One is, I think Jonathan, you mentioned the good enough part, right? So there's 2 aspects. One is like, functional conversations like this, where you're not scrambling to see, how can I get rid of this noise? How can I get rid of this echo? Or can you hear me kind of thing, right? If you start a call by saying, you expect that you can be heard, there's no noise, everything is working well, you are a judge yourself, that technology is almost invisible. So that's one for these functional conversations. And then you come to the other part. I've seen some really mind-blowing demos where you really need to be told that this is virtual when you're in a metaverse space. It's almost like the person is right next to you. So you really have to experience that. I think we've all experienced audio in real life. For functional conversations like this, it's work related. You want technology to be invisible. And to me, that is a success, where you're not finding out how do I fix this problem, where it's good enough. And then there's these new experiences where it's really getting close to real life. And since we've experienced this in real life, we should be able to judge it. But at the same time, I also want to be really clear that, you don't want to substitute any real life experience, because that has its own charm. It's just that when you cannot have that real life experience, how can you best get people to be together and simulate that? Jonathan.
Yeah, I mean, I guess one of the aspects of that is, how do you test, and how do you know what the user experience is, and gathering the feedback in appropriate ways. We were very diligent about this at Skype, and one of the first really at scale services. So when we rolled out even the slightest change to a codec or whatever, we could see the MOS scores changing. And we knew whether we made a mistake or whether we, had improved the situation. Our scores, call times, all those things were always changing, and we could correlate them. So I think the feedback loop is also important to establish and to do it in an appropriate way. But yeah, and I totally agree with you. There are 2 scenarios. One is the functional. The other is, let's blow this out of the water with new hardware and great experiences. And, I have 6 speakers around me in this very modest place, Sonos. They're not participating in this situation at all, right? Someday maybe they will, right? So, yeah.
Right.
Okay, we ran out of time. I want to thank again for coming today. It was really great having you, really great chat. So thank you very much. So we are going to take a short break, and then we will be back with our next session, which is on scaling RTC devices to large calls. Thank you.